Well, hey there, kiddos. Here's your video over domain and range applications. And so we're going to revisit domain and range and then apply it to some situations. Instead of just here's a graph, what's the domain and range, we're going to say here's a situation, how does domain and range apply to that? So our first example, the graph below represents Chris's car trip from his house to school and then back to his house. Each section of the graph represents part of Chris's trip. Use the graph to answer questions 1 through 7. Sorry, I was trying to make the whole thing fit on my screen. So we're going to talk about this trip. So Chris is in his car. He's going to school and then back home. And so the first thing we want to know is it continuous or is it discrete? Well, it's all connected, the entire thing. I can draw my pencil around it and never have to pick it up, which makes it continuous. And then the next question is, at what time did Chris begin his trip? Well, if you look at the graph, time is down here on the x-axis, and so I can see that he started his trip right here at 0, 0. So he began his trip at 0 minutes. And then he ended his trip, for question number 3, way over here at the end of the graph at 30 minutes. So using that information from questions 2 and 3, we want to find the domain. Well, the domain, remember, is the x values that a graph covers, and so from the left to the right, this graph goes from 0 to 30. So the domain for this situation would be from 0 to 30, because he started at 0 minutes and ended at 30 minutes. And so what that tells us is that Chris's trip took 30 minutes total, and he covered every value in between there. So now, number 5, we want Chris's minimum distance from home during his trip. Well, that's down here at the very bottom of the graph, here or even over here. It's at the very bottom of the graph. And the minimum distance, which is your y-axis right here, is 0 miles. He was never closer than 0 miles away. Okay? His maximum distance from home happens up here at the very top of the graph, which is at 3 miles. And so using that information, the range of this situation would be from 0 to 3 miles away. So that's using that graph, we now have a domain and a range, and we know how it applies to the situation. The domain tells us that it took him 30 minutes max, and the range tells us that he went 3 miles max, and anything in between there also counted. So let's talk about another question. So number 8 here, the graph below shows the relationship between the number of dollars a worker earns and the hours worked. So you have a picture there. You've got a graph that gives you information, and part A wants the domain for the situation. If you look, this graph has endpoints. It's got an endpoint down here, and it's got an endpoint up here. There are no arrows or anything because it is a situation. It's going to have a definite beginning and a definite end. It's not going to go on forever and ever. So let's look at our points. The domain starts down here at 0 in the corner, and then all the way over here to the right ends at 40. So what that tells me is that's the time worked, is that they worked between 0 and 40 hours. According to the information on my graph, that's what I know. Now the range for this situation, remember, is the bottom of the graph to the top. So the bottom of the graph is at 0, and the top of the graph is way up here, it looks like at 320. And if I look at the way my graph is labeled, that y-axis is the amount of money earned. So what this range tells me is that they earned between $0 and $320. So the maximum amount they could earn for working those 40 hours was $320. From that, we could probably figure out how much they get paid per hour. But that's really what it's telling us, is that they made anywhere between 0 and $320. So there's another graph. So now let's talk about it in terms of a word problem. So look at number 9 in your packet or on your notes, and it says the number of ferry boat trips F needed to transport C cars in one day can be found using the function F equals C divided by 20. If there are no more than 5,000 cars transported by the ferry boat daily, what are the reasonable values for the range in the situation described? So what they are telling me is that cars, the number of cars is, that's an S, is the domain. I'm going to rewrite that because that was ugly. The number of cars is the domain because they're asking me for the range. Which tells me that the range is the number of trips needed. So the number of trips is going to be the range because that's what they've asked for. Now it says there are no more than 5,000 cars transported, which means 5,000 is my max. Well, then we got to think about then what's my minimum? Well, you couldn't have less than 0 cars because there's no such thing as a negative car. A car is a car is a car. So my minimum would be 0. So we're going to discover what would happen at the minimum. And so if I use my function, F is equal to 0 divided by 20 because we're saying the minimum is 0 cars. Well, if I do 0 divided by 20, I get that F equals 0. So my minimum number of trips that I could take would be 0. My maximum number of trips would be based on the 5,000 cars. So it would be F is equal to 5,000 divided by 20. Which would give me 250. And so the maximum number of trips that the ferry boat would have to take would be 250. So my range would be from 0 to 250. And so what that tells me is that the ferry boat will make between 0 and 250 trips to get all those cars across. So that's what that information means. So let's do one more, number 11. So a car can travel 32 miles for each gallon of gas. The function d of x, which we'll talk about that notation in a couple of days, but d of x equals 32x represents the distance d of x in miles that the car can travel with x gallons of gas. The car's fuel tank holds 17 gallons of gas. We want a reasonable domain and range for this situation. Well, they told me here that x is the gallons of gas. So x, which is our domain, is the gallons. So the gallons of gas is the domain. That means that the miles that can be driven is the range. So for a reasonable domain, for my domain values, I know that the car can hold 17 gallons, which means that's its maximum. Well, its minimum would be 0 gallons because you can't have less than 0. If you don't have any, you can't go anywhere. So here would be your domain. It would be from 0 to 17, which means that the car can hold anywhere between 0 and 17 gallons. Okay? 0 to 17 gallons of gas is what the car can hold. Anything lower than 0 or more than 17 doesn't work, but anything in between there is fine. Now the range we're going to have to use like we did before. So our minimum we see in our domain is 0, so we would have to do 32 times 0 because our function is 32x up here. And so our minimum would be 0 miles. If you have no gas, you can go nowhere. And so 0 gallons is the same as 0 miles. Our maximum, though, is that 17 gallons. And so I can go 32 times 17, which is 544. So my maximum number of miles is 544. So my range is from 0 to 544. Which means that they can go from 0 to 544 miles with the tank that they have on that car. So that's what that domain and range means in terms of the situation. I happen to have a situation, I know the range is going to be the Y values, the domain is going to be the X values. What does it mean in my problem? And so what is it telling me when I find that? It's giving me a range of values that are suitable, that make sense for the problem. So we'll practice this tomorrow when you guys come to class. I will see you then. Have a good rest of your day.